Hi, for my final project, I'm going to be talking about normal distributions and how to standardize a set of data. Many sets of data fall within a normal distribution, which shows how often different values within a data set show up within that data. Values closer to the mean appear more often, and so they're closer to the top of the hump, and the outliers, values that appear less often and are more extreme, come near the tails, and they barely appear at all. Standard deviations are measures of how common it is for values a certain distance away from the mean to appear. According to statology, roughly 68% of values appear one standard deviation away from the mean, 95% appear two standard deviations away, and 99.7% are within three standard deviations of the mean. IQ and height are two data sets with normal distributions. So as we can see here, women's height has a hump further back than a man's height because their average height is smaller, but their distributions are both a very similar shape. And for IQ here, we very helpfully have the standard deviations mapped out. The first is between 85 and 115 points. The second distribution is between 70 and 130, and the third is between 55 and 145. So you can use probability plots to check if a standard deviation is normal. You can check it for any distribution. If the graph is roughly linear, then your distribution is probably correct, and if it's not, it's not. And essentially, to make the graph, you compare the percentiles of the sample data and the corresponding percentiles of the distribution and plot that. So if you do have a set of data which isn't actually the normal distribution, but you've checked it and it's roughly normally distributed, you can use this equation here to standardize it. So if you're trying to find the chance of between two values happening, A and B are the lower and the higher values, mu is the mean, and sigma is the standard deviation. And you use these two charts after that to figure out what the probabilities are after you've calculated the values here, and that's what this symbol here means. For example, we have here, we're trying to do a dance routine and there's a flip in it, so we're trying to figure out how much time we can allocate for the flip. So we'll just say the flip is modeled with a normal distribution having a mean value of 1 second to complete and a standard deviation of half a second. What's the probability that the time to complete the flip is between 0.5 and 2 seconds? So here I plug and chug the numbers and I end up with 0.8185% chance. Now, I'm studying photonics, and LiDAR is a technology which sends out invisible rays of light and then measures how long it takes for them to bounce back to figure out where an object is. It's kind of like radar, but better. Say I'm trying to figure out how accurate a LiDAR sensor is, I could measure what it's reading, measure how far the distance is, plot how accurate it is, and then I could make a histogram showing different accuracy levels, and then I could standardize it and use the tables to figure out what the chances are that a LiDAR is going to be a certain percentage of accuracy. That's it.